Hello, today we're going to talk about piecewise linear models. So, a piecewise linear model is a model made up of several straight line segments. So, let's look at our first example. Students are preparing meal kits for a community service project. A local store offers this pricing model as shown in the piecewise linear model to the right. So, as we can see here, this graph has several straight line segments. We have a line segment here, and then we also have a line segment here. Okay, so the first question is asking us, what is the cost per meal kit for the first 80 kits and any kits that are additional beyond 80? All right, so if we ask ourselves, what is the cost per meal kit for the first 80 kits? That means that we want to go from here to here. Okay, so we want to figure out the cost per meal kit. So as we can see here, we're going to go up $120 for 80 meal kits. All right, so we know both of those are positive. So if we want to figure out our cost per meal kit, all we will have to do is look at our slope. So for the first 80, we are paying $120 for 80 of them. So if we do 120 divided by 80, we will end up getting $1.50 each. All right, that's how much you are paying per meal kit for the first 80. Now, if we look at anything above or beyond 80, if we look here, we can use the next 2 points for the other line segment. So we're going from 120 to 240. So that means we went up 120, and then we went over from 80 to 240. So we increased by 160 here. So if you go above 80, our slope is going to end up being 120 over 160. And if we do 120 divided by 160, we will end up getting 75 cents per meal kit. Okay. Part B says, how much does it cost to prepare 160 meal kits? So if it tells us to do or prepare 160 meal kits, if I go to 160 here, I can literally trace it up and then trace it over, and this will be my cost here. So if we look and pay attention, we are labeling by 40s, but we're actually increasing by every 20. 20, 40, 60, 80, 100, 120, 140, 160, 180. So our answer would be $180. Part C says, if the cost was $202.50, how many meal kits were purchased? So we know that we have to pay the $120 for the first 80 meal kits plus 75 cents per each additional meal kit. And if that means we want to pay a total of $202.50. Okay, so All we have to do is solve that for x. So the first thing we're going to do is we're going to subtract 120 on both sides, and that will give us 82.5. And then we're going to divide by 0.75 on both sides, and that gives us that x is equal to 110. So remember, we have to interpret this correctly. So remember that 120 represented the first 80 kids. Okay, x represented the additional kids. So if we think about it, if we have 80 kids plus 110 additional kids, that's going to give us a total of 190 kids total. So that is how many kids you can get for that money, for that amount of money. Example number 2 says that the table below shows the income rate in Mathopolis in 2020. And it says we have different tax brackets and how much taxes have to be paid depending on what your income is per year. So we want to graph the tax that needs to be paid versus the income. So normally when we do this, we do use the upper bounds of your intervals. So we're going to use these numbers here for our x values, and we're going to use the amount of tax that we're going to calculate as our y values. So they say if you pay up to $10,275, you don't have to pay any taxes. So I'm going to label this point on the graph in green. So if I have that, what I'm going to do is I need to approximate where 10,275 is going to be. I can tell that every 3 indenture marks I'm going up by $50,000. So what I can do here is I can take $50,000 and I'm going to divide it by 3 because I can count over 3 units in order to hit every 50,000, and that's going to give me approximately $16,667.67 per each indention or each grid line. So if I'm looking to graph 10,275, that is going to fall below the first indention, so it'll be somewhere in here where that is, and I have to pay no taxes, which is why I put it on the axis. The next thing that I need to graph is the next tax bracket, and it says that you have to pay 10 cents for each dollar that is above $10,275. So if we're looking at the $41,775, I have to subtract $10,275 from it to figure out how much taxes I would have to pay, or how much money I would have to pay taxes on, which is $31,500, and I have to multiply that by 10 cents per dollar. So that means I need to pay about $3,150 on a salary of $41,775. So remember, if each indention is $16,666.67, if I multiply that by 2 to get the second indention, I'm at $33,333.34. So I know that I'm going to be somewhere in here when it comes to the salary, okay, where the pink line is on the axis. So because I have to pay $3,150, I already know that I'm going by $10,000 on the y-axis. And because I'm going by $10,000 on the y-axis, I know that the $3,150 is going to land me somewhere in here, because it's not quite half, but it's below half. All right. So next I need to graph the next tax bracket, which will end up being going up to $170,000.50. So I mean 170,000 dollars, $70,050, excuse me. So I have to pay the $3,150 and 24 cents for each dollar that's above 41,775 dollars. So if I subtract 41,775 from the $170,050, I need to pay an additional 24 cents for $128,275. So I'm going to multiply that by 0.24, which means that I'm going to have to pay $30,786 on that money, plus the $3,150 for me surpassing that other tax bracket, which would give me a total of $33,936. So if I want to grab $170,050, that is going to, if I start at 150,000 and I add $116,666.67, that's going to put me at $166,000 and some change. So I'm going to add another grid line to it, and then I will end up getting 183. So I am not quite at the second grid line above 150, but I am a little bit below. So I am going to be somewhere in here. Okay. So if I go to that spot and then I go up to 33,000, I hear I'm at 30,000, 35,000 is halfway, so 33,000 is somewhere in here. So that is that part of the graph. And then last but not least, it says any amount that is over 100 and $170,050. So I'm going to say, for example, 200,000. So if I'm at $200,000 and I subtract $170,050, I would have to pay 35 cents per dollar over that, which would end up being times 0.35, 35 cents. And then that'll be 10,000. Um, that will end up being $10,482.50. But I have to add in the $33,936 from the previous tax brackets, which will make me pay $44,418.50. So if I were to pay that, that's a little bit below 45,000. So I will be somewhere in here. And remember, I've used 200K as an example. So now I can connect these with my segments, since this is a piecewise graph. Okay, so that is my graph there. So now I should be able to answer questions. So the questions are asked, it says, find the amount of tax that's paid by a person who makes $175,000 a year. If you make $175,000 a year, you are in the highest tax bracket, which means that you have to pay $33,936 plus 35 cents for each dollar above $170,050. So if I take $175,000 and I subtract $170,050, I will have to pay taxes on $4,950. So I will have 33,936 plus 0.35 times 49.50, and that will give me a total tax bill of $35,668.50. That is how much taxes would have to be paid. Okay, so that'll be the taxes for that amount. All right, so that will be 0.50 here. All right, so that will be the answer for B. So now I will need to look at part C, which says if minimum wage in the UK is $8.75 per hour, find the annual tax paid by a person working for 40 hours a week, 50 weeks of the year. So we would have to say $8.75 times 40 hours a week. That's how much they make per week, $350. And I would have to multiply that by 50 weeks of the year, which will give me a salary of $17,500. So if I look at this salary of $17,500, then I would fall in the tax bracket category in the second one. So I would have to pay 10 cents for each dollar that's above 10,275. So if I take $17,500 and subtract 10,275, that means I need to pay additional taxes on $7,225. So I will take 0.10 and multiply it by 7,225, and that will end up making me responsible to pay $722.50 for taxes. Okay, so part D says Anaya has an entry level software developer and she's earning $63,917 a year. Find her net salary. So, net salary means your salary after taxes. So, after you pay your taxes, that's how much money you bring home. It's what we call take home pay. So, if I want to figure out her salary after taxes, I have to figure out how much taxes that she's going to have to pay. So she makes $63,917 a year, which means that she would be in the third tax bracket paying $3,150.24 for each dollar above 41,775. So if I know she makes $63,917 a year, I will have to subtract 41,775 to figure out her additional taxes or the money that she would have to pay additional taxes on. So that would be $22,142. So she would have to pay $3,150, and she would have to pay that plus 24 cents for each dollar over 41,775, and that would be $22,142. So 3150 plus 0.24 times 22,142, that would give her a total tax bill of $8,464.08. That's how much her tax bill would be. Right? And then it says for part E, what percentage of her income was paid in income tax? Well, she paid $8,464.08, and she paid that out of the $63,917 that she made. And we will have to have that as a decimal, and then of course to turn it into a percent, multiply by 100. So that is approximately, in three significant figures, 13.2%. That's how much she was taxed. All right. So if you have any questions on piecewise linear models, please let me or your teacher know, and have a great day.